In this course, most of the functions you'll be dealing with are linear functions. A relationship f defined by y equals f of x equals mx plus b for real numbers m and b is a linear function. Note that this is simply the slope-intercept form with f of x notation. You should be cautious with this definition. The name of the function and the variables may change, making it hard to identify as a linear function. For instance, the function p equals d of q equals 81 minus 3/4 q is a linear function. So instead of x, we have q, and instead of m, we have minus 3/4, and the b is 81. The output variable is not y in this case, it's actually p. So we can think of x and y on this graph corresponding to p and q. Supply and demand curves relate the supplier or the consumer behavior to the price. Now we know as the price of an item increases, the quantity demanded by the consumer decreases. In other words, high prices aren't very attractive to consumers. As the price of an item increases, the quantity supplied by the manufacturer increases. In other words, if you can charge a high price, you're going to want to put a lot of them out there for the consumer to buy. When consumer demand increases for a product, the price increases and the supply decreases. So as the consumers want more and more of whatever the manufacturer is putting out there, there's going to be less and less of a supply, which means it's going to start to cost more. Linear functions are often used to model this behavior. Even though the price should be labeled as input, economists generally plot price P vertically and the quantity Q horizontally. So this is a typical supply curve. It is an increasing curve. The independent variable is Q, meaning the input is the quantity of the object, and the name of this function is S to stand for supply. On this portion of the graph, suppliers are only willing to supply a small quantity because the price is so low. On this portion of the graph, suppliers are willing to supply a higher quantity because of the higher price. As the price gets higher, the suppliers make more quantity available. Now, this is a typical demand curve. It is a decreasing function that describes the consumer's behavior. The letter capital D is used for demand. When the price is high, the quantity demanded by the consumer is low because we don't like to pay a lot for things. We're inherently cheap. When the price is low, the quantity demanded by the consumers is high. So if we put these two together with a particular example where P is the price in dollar and Q is the number of batches of licorice, we can start to make some observations about this graph. So let's go ahead and put 20 into our supply function. That means we're putting in 20 batches of licorice. When I substitute that into my formula, I get 3/2 times 20, which gives me 30. This means that at a price of $30, 20 batches will be supplied by the supplier. If we try and find D of 80, which means 81 minus 3/4 times 80, that simplifies to 21. This means that at a price of $21, 80 batches will be demanded by consumers. And you can see the corresponding point on the graph. Let's go ahead and put 36 into each one of our functions. So S of 36 is equal to 3/2 times 36, that's 54. D of 36 is equal to 81 minus 3/4 times 36, that's also equal to 54. So that means that at a price of $54, the quantity supplied by the manufacturers is the same as the quantity demanded by the consumers. This point is called the equilibrium point. In other words, what the suppliers want to supply and what consumers demand is exactly the same. Now this equilibrium point can be found graphically or algebraically. In the previous example, I just simply plug some points in and observe that I got the exact same ordered pair. But in general, what we'll do is we'll set the supply function equal to the demand function. So if I go ahead and put in my two formulas here, I get 3/2 Q equals 81 minus 3/4 Q. If we get a common denominator of 4 and then add 3/4 Q to both sides, that goes ahead and simplifies to 9/4 Q equals 81. To get the Q by itself, I'll multiply both sides by 4/9, and that gives me Q equals 36. And that's the same exact value that we got before. If I needed to find what the actual price was, I'd go ahead and plug that 36 into either one of those formulas. So now let's look a little more carefully at our graphs. Let's pick a price above the equilibrium price. Remember, the equilibrium price at the point of intersection was actually 56. So here I'm picking a price up at $70. Notice that the quantities corresponding to these prices are different. The quantity about here is somewhere between 10 and 20, and the quantity here is out around 50. So more specifically, at a price of $70, about 15 batches are demanded by consumers and 47 batches are supplied by the manufacturers. What do you think that means? Well, this corresponds to a surplus because the manufacturers are supplying more than the consumers are actually demanding. In fact, if we are anywhere above the equilibrium price, that same situation is going to hold. It's just a matter of degree of how much more the suppliers are supplying than the consumers actually demand. Now, let's look at a price below the equilibrium price. In this case, let's go ahead and look at a $30 price. At a price of $30, about 67 batches are demanded by consumers, and 20 batches is going to be manufactured by suppliers. So what do you think that means? In this case, the consumers want 67 batches and the suppliers only have 20 to supply. That situation corresponds to a shortage. If we were to pick any price below the equilibrium price, below 56, we'd have the same situation. So in fact, we get the picture we see here. If we pick prices anywhere above 56, we're going to get a surplus. Anything below that, we're going to get a shortage. By examining whether the price is above or below the equilibrium price, we can always determine whether there is a surplus or shortage in effect at that price.